Just as there are some things in life that money can't buy, there are some numbers in the reals that straight edge and compass cannot construct. So we look at some things that cannot be constructed today. We'll use the criterion that we discovered last time, that if a real number is constructible, then it generates a field whose degree is a power of 2. So the most famous example of something that can't be constructed is we cannot trisect an angle using straight edge and compass. In order to establish this, all we need to do is find one angle which cannot be trisected using straight edge and compass. So in order to do that, let's think about the construction of angles for a moment. So construction of an angle. So let's start with our usual point O, our usual 2 points which are given to us, namely O and A. And let's say we want to construct an angle theta. So we just construct angle theta here. Now this distance is unit 1. We can also mark it off along this arc here. So this is also, let's also take this to be 1. And then this point P here has coordinates cos theta, comma sine theta. Okay, so if the point P can be constructed, then we can also construct the length, the real number cos theta is constructible. So P is constructible implies that cos theta is constructible. And if cos theta is constructible, then sine theta is square root of 1 minus cos square theta. Sine theta is in a quadratic extension of the field containing cos theta. So sine theta is also constructible, and therefore, since the x and y coordinates of P are constructible, P itself would be constructible. So this is an if and only if construction. So what we'll say is that an angle theta is constructible if and only if cos theta is constructible. Because if this angle theta were constructible, we'd be able to mark off a point at distance 1 along this ray, and we'd be able to construct the point 2. So this is our working definition for an angle being constructible, that cosine theta is constructible. So for example, the angle pi by 3 is constructible. Why? Because cos pi by 3 is 60 degrees, it's just half, which belongs to Q, and every rational number is constructible. But here's the second example. Pi by 9 is not constructible. And let's see why this is not constructible. So let A be the number cos pi by 9. Okay, so we'll use the triple angle formula, which says that cos 3 theta is equal to 4 cos cube theta minus 3 cos theta. So now we have A equals cos pi by 9, and so this is theta. 3 theta is pi by 3. So what we get is pi by 3, cos pi by 3, which is half, is equal to 4a cubed minus 3a. So what we have is that A satisfies the equation um, 8x cubed minus 6x minus 1 equals 0. So it's a root of the polynomial 8x cubed minus 6x minus 1. Now I claim that 8x cubed minus 6x minus 1 is irreducible. Now, if it were not irreducible, it would have at least one linear factor, because any factorization would either be into a polynomial of degree 2 and polynomial of degree 1. Well, there's no other possibility, or 3 polynomials of degree 1, but it would certainly have a linear factor. So, so to prove this, it's enough to show that this has no root. It has no linear factor means that it has no root. In Q. So this, when I say irreducible, I mean irreducible in rationals. So we need to show that it has no root in Q. So suppose that we had a root. Suppose we had a root x equals p by q was a root. And by cancelling common factors, we can assume that the GCD of p and q is 1. So the fraction is given in lowest terms. Then what we have is 8p cubed minus 6pq squared, just multiplying through by q cubed, minus q cubed is equal to 0, which is the same as saying that 8p cubed is q squared into q plus 6p. Now p and q are co-prime, so this means that the only common factors of q can be with 8, and so this means that q squared divides 8, which means that q equals 2 or q equals 1. Okay, so if q equals 2, this means that p has to be odd, because p and q have no common factors, and what we get is 2p cubed, is equal to 2 plus 6p, which is 2 into 1 plus 3p. So we cancel out this, we get, maybe we can just remove this middle step. So we get p cubed is 1 plus 3p. But p is odd, then 1 plus 3p is even, but p cubed is odd. So this is a contradiction. So it's not possible that q is 2, that means q is 1, which means that this 8p cubed minus 6p minus 1 equal to 0 has an integer solution in P. But now you just take residues mod 5, just check for P equals 0, 1, 2, 3, 4. This equation 8p cubed minus 6p minus 1 is not congruent to 0 mod 5. If you had an integer solution, it would also be a solution mod 5. But since this equation, you can just brute force check that it doesn't have a solution mod 5. And since it doesn't have a solution mod 5, it cannot have an integer solution. So what we have is that 8p cubed, 8x cubed minus 6x minus 1 is irreducible. So conclusion is that the degree of cos pi by 9 over q is 3, which implies that cos pi by 9 is not constructible, because 3 is not a power of 2, right? And this actually implies that not every angle can be trisected, because the angle pi by 3 cannot be trisected. So when we say an angle cannot be trisected, it means that you're given the angle and then you have to construct using straight edge and compass 1/3 of the angle. But if you're given pi by 3, it's not really that you're given anything, because the angle pi by 3 is already constructible. So no new points are given that you could not have otherwise constructed, right? So given an angle of pi by 3 doesn't really give you anything, and you cannot construct cos pi by 9, so you can never construct an angle of pi by 9 even if you're given an angle of size pi by 3. So pi by 3 cannot be trisected, and so in general there's no algorithm using straightedge and compass to trisect an angle.